All right, so we got to figure, like, exponents can be negative too, but they do something very different. They don't change the value to be negative. They do something very different. So a long time ago, I learned about these up-down charts, and I always find them helpful to work with. Okay, what's 2 to the exponent 1?
Oh, never mind. No, I'm not answering this.
What's 2 to the exponent 2? 4. Okay. 2 to the exponent 3? Still not going to answer your hand, Rahat. 8. Good job. And 2 to the exponent 4? You can just say it.
16.
Brilliant. Okay. So if we go up the chart, how do we get from 2 to 4?
2 times 2?
Okay, so we're timesing by 2. And to get from 4 to 8?
4 times.
4 times. So again, we're timesing by 2. And to get to 16?
Times 2.
Times 2. Okay, everybody's good with that?
Yes.
Good job. We're doing those in grade 12 right now. Okay. To get from 16 to 8. 16 to 8. What do? We multiply by 2 going up the chart. What do we do going down the chart? Divide by 2. And to get from 8 to 4, we divide by 2. And to get from 4 to 2, we divide by 2. So as we go down the chart, we're going to fill in some stuff. So what's 2 divided by 2? What's 2 divided by 2?
2 divided by 2 is 2.
No. What's 2 divided by 2?
1.
1.
2 groups divided by 2 groups.
Oh, that's good thinking there. Okay, what's happening to the exponents on this side as we go down the chart? They're going down by 1, right? We're reducing them by 1. So 0, if I reduce it by 1, I'll be at negative 1. Now going down this side of the chart, we said that we divided by 2. Okay? So what's 1 divided by 2?
0.5.
0.5. I'm going to write it as a fraction. Is everybody okay with that? All right. So this goes to negative 2. So 1/2 divided by 2. How about you just tell Jonah you'll get back to him?
Wait, Miss John.
Yep.
What if when you're doing negative exponents is just 1 and then 2 or whatever our what do you call the big number?
The base?
The base, and then we multiply the base in the denominator. So then
I think I know what you're saying.
then we get 1, 4.
Yeah.
And then if you get 2 minus 3, that will equal 1 and 2 times 2.
Okay. Thanks for that. I got it. Okay. Thank you. Okay, so when we go to here, we're dividing by 2. When we go to here, we're dividing by 2. What's 1/4 divided by 2? Do you guys know how to handle that? Like, do you guys know mathematically? So if I say 1/4 divided by 2, can we write 2 as a fraction?
Yes.
Yes, what would it be?
2 over 1.
2 over 1. So with fractions, we never divide them. We multiply by the, do you remember what we multiply by? The reciprocal. What does reciprocal do? It flips it upside down. So we're going to multiply by 1 over 2. And so what does that give us? When we're multiplying fractions, we're straight across the top, straight across the bottom. So what's that going to give us? 1 over 8. And that would be 2 to the exponent negative 3. So what do you guys notice? Do you notice a connection between, let's look at this one. 2 to the exponent negative 3 is equal to 1/8. What's 2 to the exponent positive 3 equal to? It's equal to 8. Do you notice a connection here? 2 to the exponent positive 2 is 4, but 2 to the exponent negative 2 is 1/4. So what we call that is a negative exponent reciprocates the base. Reciprocal just means to flip it upside down. And if it doesn't have a denominator, you're going to put it over 1. Okay, let's try with the 3 charts. So if we start at 3 to the power of 1, that's going to give us 3. 3 to the exponent 1 is 3. 3 to the exponent 2 is 9. 3 to the exponent 3 is 27. And 3 to the exponent 4 is 81. So as I go up the chart, what am I doing? Multiplying by what? 3. So when I go down the chart, what am I doing? Dividing by 3. Okay, so it's 3 divided by 3.
1.
1.
Finally.
So 3 to the exponent negative 1 is going to be what? Okay, let's leave it as a fraction though, because I think that'll be nicer. What would it be? Sorry?
3 over 9.
Or let's reduce that. 1/3.
How's it 1/3? Oh yeah, 1/3.
Yeah.
So 3 to the exponent negative 2, if you just want to look at what 3 squared is, it's going to be the reciprocal of 9. So what's the reciprocal? We're going to flip that upside down. What's the denominator on 9? It's got the invisible number 1 underneath it. So if we flip it upside down, it's going to be 1/9. And then 3 to the exponent negative 3 is going to be 1 over 27.
So it's 1 over what it would be if
It was positive, yeah. Yeah, it's the reciprocal. So 1 over 81.
divided by that.
Yeah, exactly. Yeah,
Fractions are division.
exactly. Fractions are division. So these I find, so what you need to know about negative exponents is they don't change the base negative. They actually ask you to reciprocate the base. Okay, reciprocate the base. All right. We're going to evaluate each power here. 5 to the exponent negative 2. So you can write this as 1 over 5 to the exponent positive 2. And what's 5 squared? 125. Yep. So I wouldn't put these into decimals. I'd leave them as fractions because I think that's going to be a lot easier to deal with. Okay. All right, so if it is a negative 2 and it's on the bottom, where is it going to move? You're going to flip it. If it's on the bottom, it's going to flip to the top, right? So the reciprocal of 1/5 is going to be a positive 5. So that's going to be 5 squared. And that'd be over 1, but I don't need to write the over 1 part. And that's going to be a positive 25. Because what kind of exponent do I have? A negative exponent, so it's going to tell you to flip it. That's what the negative tells you. If it was a numerator, flip it to the denominator. If it's in the denominator and it's a negative exponent, move it upstairs to the numerator. Okay, do the next one. Hint, hint, nudge, nudge, it's in the chart. So the base gets reciprocated. So it was 3. The reciprocal of 3 is 1/3. And if we already reciprocated it, now the exponent, we've done the math that the negative told us to flip the base. So we're going to be 1 over 9. Because that would be equal to 1 squared over 3 squared. Okay, so this one is already a fraction, but the negative tells us to flip the base. So what happens? It was negative 3 over 4. What is it now? Flip it. Does it matter if my negative goes on top or bottom? It doesn't, but it should only go in one place. So that's going to be negative 4 cubed over 3 cubed. So what is 4 cubed?
64.
But it's going to be a negative 64 because it was negative. And 3 cubed is 27. So the negative tells you to flip your base. Easy. It is easy when you get the hang of it, but it does take a little bit. Probably.
Yeah, Miss Gavin, I was doing quadratic equations the other day.
Yep.
So when did you start quadratics?
Quadratics happen in grade 11.
They're so
I don't think it.
they're easy.
My thing just stopped. Okay, so then I'm just going to slide it up. You can see the bottom. Okay. Trust me, you can't really forget anything. You can forget it, but I'm still going to. True story. I'll always expect you to remember it. Okay. So this is a combination of Friday's lesson and today's lesson all mixed into one. Okay? So what does the negative exponent tell me to do? So it's going to tell me to flip the base. So my base number was 16 over 9. So what is that going to be now?
9 over 16.
9 over 16. My exponent is positive now. It's 3 over root 2. So 3 over root 2, what does the 3 tell me? That tells me what kind of exponent I'm dealing with. And the denominator tells me
The root.
the root. I really hope the rest of you are just being quiet and that you do remember this. So looking at this, would you square root first or would you cube them?
Square root first.
How come,
No,
Rahat?
I mean cube.
I would square root,
Yeah.
How
square
come,
root.
Steve?
because it's easier to do the square root if the numbers are small.
True story. And are these perfect squares?
Yes.
They're both perfect squares. So we know they're going to square root nicely. So I'm going to go ahead and square root first, and then I'll apply my cube. So knowing your perfect squares and your perfect cubes is handy because you can make some better decisions. It will work if you do it the other way, but you're probably going to need a calculator. So I'm going to take the square root of 9 over 16, and I'm going to cube it. So what's the square root of 9? 3. Square root of 16
64.
is 4.
It's 4.
Oh, sorry. I thought the wrong one.
Where did the 2 go?
Died?
Are you just doing this to me, Dion?
Oh no, the cube.
So
is
what does
square
the root tell you? It tells you it's the square root, so I wrote it as a radical instead of... So you don't, because you put it somewhere else, right? So 3 cubed. What's 3 cubed? 27, thanks. And 4 cubed? 64. Can that be reduced? No?
No.
Okay,
Yeah, definitely no.
okay. All right. Okay, so step 1, the negative exponent is going to tell me to flip the base. So I would encourage you to apply that negative to either the top or the bottom. It doesn't really matter which one, but you should put it somewhere. So this is going to be, I'm going to say negative 8 over positive 27. My exponent changes to positive. My exponent does not flip. My exponent doesn't flip, okay? Just the base.
So does it equal to negative 243? Oh, no. No.
Okay, so the numerator tells me what kind of exponent I'm dealing with. The denominator tells me what kind of root I'm dealing with. So would I cube root or would I do the exponent 5 first? I'm going to cube root because both of those are perfect cubes. So I'm going to take the cube root of negative 8 divided by the cube root of positive 27, and all of that is to the exponent 5. And I've written them different ways. In this example, I wrote them all under one root sign, but whether I do it like this or whether I do top and bottom, doesn't matter. Doesn't matter. So what's the cube root of negative 8? What's the cube root of 8? 2? But it's a negative this time, so it's going to be...
Wait. How do you get minus 2 5? How do you get 5?
Oh my goodness, guys.
Oh, that was hilarious.
Today is a hard to follow.
Bro, that was back. I was on vacation.
Miss Karen, can we put this down?
Just one sec. Steve's writing this down. Arun, zip it. Okay. Steve, are you good? Can I move that up? So what's your question, Rahat?
No, hang on. No, I'm just blind and really stupid at the same time.
So when you cube root something, I'll just say this because this happens a lot. If you cube root or you square root something, once you've done that math, you don't rewrite the root sign. Like you've done the cube root of negative 8 and it equals 2. So those two things are equal. So they replace... Who? What? It is positive. Yeah, I wrote a plus sign there. Okay, negative 2 to the exponent 5. And 3 to the exponent 5? What's 81 times 3?
243.
Nice.
That's what happens if you choose the bathroom.
Stop it, Arun.
Get this mother to show.
Okay.
Oh. It's the practice.
Okay. I would like you guys to do this one. I want you guys to do this one. I'm going to do it, you're going to do it. The negative 32 to the exponent negative 2/5.
Where is the shark? What did the shark call it?
Pardon?
What did the shark call it?
I saw a share this morning.
Yeah, it's called illegal.
Hey, Miss Karen, did I miss a single class of this class?
I don't know, bud.
So this last one. Brad, take tomorrow off from your power. Am I a bit high?
Yeah.
That's not a fraction. So I have a bad compliment. Won't work. Wait. I don't know. I gotta figure it out. Just a very Jane. What's your name? So that's the same thing. Wish me happy. Bro, I got Steve. What's going on? Well, Steven's coming. Linda. Brayden. What's all? All around. Brad. It was the only one. I wish this Miss Connie, did you wish her a happy birthday?
I didn't because he wasn't here.
She sent an email. You never emailed me. Yeah.
You didn't
I
email
was
me.
waiting
You
for
did
you.
not email me to ask what you missed. So I figured you were.
Happy birthday.
Yeah, I know you did. I love you, man. Getting knocked out. Miss Connie, I thought you were gonna care about me emailing me happy birthday.
Sorry, man.
Alright, kind of hurts. Just next year though?
Next year, I'm on it. I'm gonna put a reminder in my calendar right now.
You and I gave it up.
So much furious right now. I said, bro, why does this class feel so bad? What did he do? He said, my broker had to see my new come here.
Okay, can I show you?
Yeah, show me.
Did you get it done? If I were to walk around, would it be done?
Nah, close enough. Oh my, that's not what I got. Well,
Okay, so the negative exponent tells me to flip, and it's not a fraction, so I have to make it into a fraction. So originally, it's like saying it's over 1.
I didn't know how to do that.
Yeah, that's kind of been the lesson. Just cutthroat here.
Sorry, it's hard.
So my exponent doesn't flip, okay? Like that stays the same. That's really important. So then it talks about my exponent of 2, my root of 5. I know 5 is, 32 is a perfect fifth. So I fifth root the top and the bottom. I get 1 over negative 2, and then I have to square them. And I should get 1/4 as an answer. Easy. So what do I have to do with the next one? This is from Friday. What do I have to do with this? 1/5. What do I have to do with it? Or 1.5. Convert to a fraction. Yeah.
What's this one? This lesson?
This was from Friday.
Wait, what? Did you get 1/4 on the last question?
Yes, I did.
Thank you so much, Miss Kelly.
Wait, what did
Okay,
you
so this is going to be negative 15 over 10. Can I reduce that?
Yeah,
Yeah.
What's it going to be?
3 over 2, or negative 3 over 2.
Negative 3 over 2. So I'm going to have 0.16 to the exponent negative 3 over 2. It might be helpful to write your decimal, your base decimal, as a fraction. You could use your calculator too. That'll work. But what would this be as a fraction? Your base number as a fraction?
1610.
Nope. What place value is that 6 in?
The 100.
The 100. So it's going to be 16 over 100 to the exponent negative 3
425.
over 2. Still no.
What?
No.
Don't you got
Like we reduced it.
I'm not going to reduce it because that's going to mess me up. Well, I guess it won't mess me up later, but
No, but this is a nice number.
it is a nice number. Why is it a nice number, Rahat?
Since both of them are perfect squares.
Perfect squares. Okay. So the negative tells me to flip the base.
Mario Kart is.
So this is going to be 100 over 16 to the exponent negative 3. Oh, not negative 3. I already flipped. So it is positive 3 over 2. So this is going to tell me the kind of root. The denominator tells me the root. The numerator tells me the exponent. So are you going to root or you're going to exponent? I'm going to root.
64 what?
Does it matter what order we do it?
Nope. It's just whether or not you have to use a calculator. So my root was applied and I put it in root form. So I've got 10 over 4. cubed.
That's a lot, man. That's 1,000 and something else.
What's 10 cubed?
1,000.
Is it 1,000?
10 cubed equals to 100. Oh, 1,000.
1,000 is correct.
1,000, yeah.
Got that.
You did. And what is 4 cubed?
64, I don't know.
Could I reduce that?
Is it 64?
125/8?
It is. 125 over 8? Are you sure?
So why don't I just divide it by 2, on and on and on?
I don't know, I feel like
For like millennia.
I feel like you're wrong.
Is it correct, Miss Galligan?
Mm,
No. No. You can do.
yep.
125. Well, I just divided 1,000 by 8.
Could I have reduced it right off the hop or right here? Could I have reduced it? If that was 5 over 2 and then cubed, what would I have got? 25, or sorry, 125 over 8. Is that not the same answer? So you could have reduced earlier and got the exact same answer. Okay, now we're going to throw some word problems in. Just to sprinkle the fun around.
Yeah, I'm seeing these questions.
Okay.
I want to become like
Okay, paleontologists. You guys know what those are?
Yeah, isn't like that thing? The dinosaurs.
Dinosaurs, guys. The dinosaur guys.
It's the one that Ross does.
People, not necessarily guys. Paleontologists use measurements from a fossilized dinosaur track and the formula, this, to estimate the speed at which the dinosaur traveled. Okay, so it gave you the formula, folks. There's your formula here. In the formula, v is the speed, okay, and it gives you the units, meters per second. S is the distance between successive footprints of the same foot. So what does successive mean? One after the other, right? And F is the foot length in meters. So F is the foot length. Use the measurements on the diagram to your right to estimate the speed of this particular dinosaur. So the foot length is F, and this 1 meter here would be your S value. Okay, so we're going to fill in what we know for the formula. So V is equal to 0.155, S, which is 1, to the exponent 5 over 3, and 0.25 to the exponent negative 7 over 6. Really important that you pay attention, read the formula really well. That negative there is really easy to miss. All right. So we're probably going to end up having to use our calculators for this, but this one I can do pretty easily. What's the cube root of 1? And what's 1 to the exponent 5? Still 1. Okay. Now this one, we can put this into our calculators, ladies and gentlemen. We can put this into our calculator. So you probably want to give it a shot.
What are you doing, Miss Kelly? Which one are you trying to get in your calculator?
This one right here, Rahat. Because I already solved this one. The cube root of 1 is 1. 1 to the exponent 5 is also 1. Maybe I'll use this one. We could. Oh, my calculator's not on. All right. Okay, so we need to do some stuff with our exponents. So our base number I'm going to put into brackets, so 0.25. And I'm going to use my exponent button. And my exponent is negative 7 divided by 6, and I got to close my bracket. I'm asking you to put in your calculator. So I'd like you guys all to try it.
What's the one in the middle? The little symbol?
You have that arrow. It should be right above your division. Right above your division key.
What's it do?
It's your exponent button.
Oh, exponent do it.
The exponent that's in the formula. So in this case, it's kind of nice. Like, it's not going to be a beautiful number. So I'm just going to put that in. I'm going to hit equals. And is that an irrational or is that a rational number? Irrational or rational? Irrational. Doesn't repeat, doesn't end. So I'm going to put all of that in there. 5.0396842. So my question is did you all get that same number by putting it in your calculator? Yeah? Okay.
I did not get the same number.
Okay. So figure out how to enter it into your calculator.
0.25 and exponent -7.
But you should probably put your exponent in brackets.
Well, I don't have the option.
That's
What are you doing?
I don't know.
Leave the bracket button.
Your brackets are right here.
But it doesn't work.
Okay, so 0.25 to the exponent, bracket -7 divided by 6.
White, my boy, white Capri Sun.
Oof. Let's do this. So that's the order. 0.25. Exponent, brackets, -7 divided by 6, bracket. I do not know why that's not working.
Am I buying a calculator?
Maybe.
Okay, do I need one of these boys?
No, you don't. But I don't know how this works.
I'm allowed phones from
Nope. No, that's an answer. No. I don't know how to make this work on your calculator. Try a couple of different things. I don't know. Sorry, bud. Give it a try, because try a few different things. Try it without the brackets. Okay, next up, these are all multiplied together, so we're going to multiply them.
Oh, I nailed it. Wait, Miss Caroline, so the -7 is the exponent, right? And then moved by 7.
We'll round to 2 decimal places, but we need a units of measure here.
Oh, I got it.
Oh, you figured it out?
Yes.
Perfect. Pardon? What was it? Meters per second.
Well, is it like physics?
Kind of, yeah.
It's like physics. I'm dropping.
Perfect.
Physics is fun.
All right, so that's negative exponents. So you got to remember that the negative tells you to flip the base. Flip the base.